In this video, we're going to take a look at naming carboxylic acids. Now, carboxylic acids, if we just take the carbon and the double bond O and then the OH like this is our carboxyl group, and this would be the simplest carboxylic acid. It has only one carbon atom on it. And what we do is we take the longest carbon chain and we take the carboxyl group here, and we just assume that's on the first carbon. We just make that arbitrarily the first carbon, and then we don't have to add one to it. We just assume that it's going to be the first carbon here. So this here with only one carbon atom here would have like the base root of methane, but then we change the ending to oic acid. So instead of methane, M-E-T-H-A-N-E, instead of methane, this becomes methanoic. Methanoic acid. Methanoic acid. And there'd be a space between the C and the A here. They're two separate words. So this becomes methanoic acid. And if we had two carbons on here, so if I went carbon, carbon, double bond O like this, and then OH like this, then that goes from ethane to ethanoic acid. Ethanoic acid like that. And we don't put a 1 on there. We just assume that the carboxyl group is on the first carbon atom. Okay, now we could have dicarboxylic acids. And so if we had, say, 3 carbon atoms in a row, 1, 2, 3, like this, and then we put our carboxyl group here, and our carboxyl group here, like this. Okay, there's 2 of them here. The base of this would be propane. The base of this would be propane. So our base on this is propane, and we're going to have 2 carboxylic acids on this. So this becomes propane dioic acid. So dioic acid. Dioic acid. And you might be thinking maybe that, well, maybe there should be another I here, dioic acid, but it just doesn't roll off the tongue very nicely. And, you know, did I mention chemists are lazy? And so they just kind of put it together like this, propane dioic acid. And then if we were to say throw something else on here, I don't know, like a chlorine atom. Let's just say that we had a chlorine atom. Hang on, gosh, somebody's been sniffing my markers. Okay, let's try a chlorine on here like this. Okay, now this here is coming off of the second carbon in the propane molecule here. So this becomes 2-chloro-propane dioic acid. We do have some common names for carboxylic acids. That is to say, people started calling these things something before people got together and came up with the official rules. So these 2 very simple carboxylic acids have some special names. Now this one right here with the methane, it is just a single carbon atom. Single carbon atom, this is known as formic acid. Formic acid. And this gets its name from, I believe it's Latin, and formica, which is Latin for ants. And so if you've ever been stung by a red ant, or if you squeeze red ants and you get a little bit of juice out of them, I don't know why you'd want to do that, but I guess if you did, that is formic acid, this one right here. Okay, so it gets its name from ants. And then this one here, this is acetic acid. acetic acid, and that also has kind of another common name for it, and that is vinegar. And so vinegar comes, this is I think it's Latin. Latin acetic means vinegar. And if you're like a biology person, if you ever take anatomy, physiology, there's your hip bone, and where the femur attaches to your hip bone. So you've got like this cup like this, and then the femur, the head of the femur hits the hip bone like this. That cup is called the acetabulum. The acetabulum. And it's spelled acetabulum like this. And what it means is that it looks like a vinegar bowl. When I took anatomy way back when, I was wondering, gosh, did that mean like the Roman people were taking people's hip bones and throwing vinegar in it and using that to dip their bread in? And my anatomy professor thought I was really weird when I mentioned that. But anyway, acetic acid or vinegar is just a common name for ethanoic acid. 2 carboxylic acids that you might encounter in your everyday life. Well, you might encounter vinegar, and we talked about that one. Formic acid, maybe not so much unless you like squishing ants for some strange, bizarre reason. But 2 other common ones are ibuprofen and naproxen. Now they have structures that are similar. They're both carboxylic acids, but they're also a little bit different. And so if I start with the structure for ibuprofen, ibuprofen is an aromatic hydrocarbon. So we've got aromatic benzene ring, looks like this, okay, like this, all right. And then up here we're going to have like this, and then carbon, double bond O, and then OH. Okay, so here's ibuprofen. And then naproxen. Naproxen is a similar structure, in that we have a benzene ring here that looks like this. Okay, benzene ring. And that's going to be attached, let's see, it's going to have something very similar, like this. Carbon, double bond O, OH, just like the ibuprofen over here. And then we're going to have another benzene ring, like this, okay, and like this. Okay, now this here is ibuprofen. Let's see if I can remember how to spell that. Ibuprofen, F-E-N, ibuprofen, okay, and then naproxen. Naproxen, okay. So these 2 carboxylic acids are pain relievers. That is to say that they're analgesics, okay? And people take these as pain relievers, and what you can see that they have in common is this part of the structure right here, like this, okay, is the same on both of these molecules here, where it is 1, 2, 3 carbon atoms, and then a carboxylic acid here. So this here would be a propanoic acid, okay, propanoic acid, and then attached to this aromatic thing here, propanoic acid attached to this aromatic stuff right there. Okay, so these 2 work pretty darn slick, and you see that they have similar structures. And you might say, oh, well, does it really matter? As long as we have a propanoic acid, we can just attach anything to it, and it'll be a pain reliever. Well, not quite so much. So the thing is these aromatic compounds like this and all this other stuff that's attached, the electrons get pulled in different directions and such, and it causes just enough pull on the structure here that it creates a certain shape that makes this here an analgesic, and the same thing over here. So it's not just that we have the propanoic structure there. I mean, that certainly is a big part of it, but it does depend what else we have attached to it. Now, the neat thing about these 2 molecules, like, well, why would I choose one of these over another? Now, it turns out that naproxen has the brand name of Aleve, and Aleve lasts longer. So this has a longer analgesic effect, okay? So you don't have to take as much of it, or you don't have to take it as often as you might say ibuprofen. The downside is, though, is that both of these might cause some stomach upset and or intestinal bleeding. And naproxen a little bit more so than the ibuprofen. But anyway, those are two carboxylic acids that you might encounter in your everyday life: ibuprofen and naproxen, or Aleve.